Okay, welcome back. Now I'm going to do a demo I'm calling the electromagnet. I'm going to illustrate the principle of an electromagnet. In physics, we learned that when you pass electricity through a coil of wires, that it creates magnetism. And then we can use this as a tool called the electromagnet to make objects stick to each other. So I have here, I'm going to show you guys, the simple electromagnet. Right? All it is a battery, and then it's connected here through a coil of wires, right? So then when I connect this battery, when I connect the leads of this wires to the battery, you will have current running through this, right? And that will create magnetism, and then I'll be able to stick this metal to it, and then the two iron metals will turn magnetic, right? And then they will stick, and I will be able to hang heavy weights here. The manufacturer says that you can actually put 200 pounds of force here. So I'm going to be testing that out. In industry, electromagnets are used a lot to be able to lift heavy cars in the junkyards and scrap metal, very heavy scrap metal. So let's test this out now. Okay, so I'm going to pass this rod through here. Okay, now you can see when I try to attach this, it does not attach, right? So you can see that it's not magnetic to begin with. Okay, so then I'm going to connect the leads of this wires across the battery, and then let's see if this stick. As soon as I bring it close, okay, the two metals stuck together, and I can't even align them so that the edges meet because it is so hard, the attachment is so hard, I can't even separate these. Okay, well, let's try to start hanging weights from this. Okay, I have got this hanger here. The hanger itself is 1 kilogram and it's really, really heavy. Okay, so then I'm going to start attaching weights to this. Okay, each of these weights is 2 kilograms. So let's start attaching these weights here. 2 kilograms, so that makes it overall 3 kilograms. Okay, pull on it. See, it can withstand 3 kilograms. Now let's add more. That's going to be 5 kilograms. Still holding steady. That's going to be 7 kilograms. I've got 11 weights, each one is 2, so that's going to be 22 kilograms and 23 kilograms with the hanger. One more, that's going to be 25 kilograms. One more, here we go. The hanger is completely full, 25 kilograms, right? How many newtons is that? 25 kilograms. 1 kilogram is approximately 10 newtons, right? 9.8 newtons to be exact. But that's 250 newtons of force. In terms of pounds, what would that be? 1 kilogram is 2.2 pounds. So to convert to pounds, you double the 25, that's going to be 50 pounds. And then 0.2, that's going to be 55 pounds, right? 55 pounds. That's about the regular luggage that an airplane allows you to take with them, right? The weight of a luggage that is allowed, 55 pounds. And we're still not breaking the bonding here. The manufacturer says you can put 200 pounds. So actually, I can even hang there. I'm about 200 pounds. I can even hang there, take these hangers off. I can hang, and it should be able to support my weight. So you can see here, if this was a more powerful electromagnet, the ones that are used in industry that are bigger, and it's got a lot more voltage going through it, it would take a lot of force to break that apart. They can hold tons and tons of weight, and they can be used to lift heavy metal junkyard, the cars that are broken up and everything. So it can be used for a lot of good uses in industry. Now what will happen, let's see an interesting result. If I take all the weights out, okay, when I take all the weights out, and I take the hanger out, you see an interesting phenomenon. See, right now I can't separate them. Now, when I take the batteries apart, right, when I take the lead apart, you would think that this would come off right away, right? Let's say if I put a 1 kilogram mass, right? The battery's not even connected now, right? The battery's not even connected. Why isn't the hanger folding? What's happening here? Somehow the iron on the two sides, the top and the bottom, are retaining the memory of their magnetism, right? They're retaining that memory, because what is magnetism is the alignment of the different domains in the magnet that when you got electricity running through it, those domains all lined up with each other, and they're retaining the memory of that. So now they're still magnetic, even though I haven't connected the electricity to it, right? Now if I break that bond, maybe add some more weight. Let's see how much weight they can take now. See, even though the wire is not connected, it's still taking 3 kilograms of weight. Now if I put another one, I'm going to hold this kind of carefully. That's 5. That's 7. Okay, so it broke the bond, right? So they were, without the wire connected to them, they were able to hold 2, 4, 6, and 7 kilograms. On the, when I put the next 2 kilogram, 9 kilograms, then it broke the bond, right? So now they lost the memory of the magnetism. Very interesting result, right? This is called ferromagnetism. That means you can turn a metal magnetic and it retains the memory of that for a while, right? That's ferromagnetism. They're not permanent magnets, but you can see that they become magnets and they retain the memory of that, right? Now if I try to connect it, right, no longer. They no longer have the memory of that. So I would have to reconnect the wire in order to turn them into magnetic, right? So you can see a lot of good ideas come out from this. You can hang a lot of weight, and you can see the idea of ferromagnetism, that two metals can turn magnetic and can retain the memory of that magnetism for a while until you disconnect, until you apply enough force to break that bond, and then they stop becoming magnetic and they turn back to becoming regular metals, okay? Thank you very much.